Hello everyone, my name is Vivek. I am a software developer. I make videos about containers, Kubernetes, distributed systems, Go as a programming language, and sometimes about software engineering in general. So if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to look into how we can write a Kubernetes custom controllers. Prerequisite for this particular video is going to be a playlist where I have explained how to use client Go library to write applications that are going to talk to Kubernetes API server. So I would highly recommend watching that playlist before continuing this video. Now, if we talk about the use case that we are going to solve or the custom controller that we are going to write, let's assume we have a Kubernetes cluster, and if we have to deploy an application in this Kubernetes cluster, let's say uh, D1, if we want an external user to be able to access this particular application, what we have to do is we have to create a service and an ingress resource in order to enable this user to access this application that is deployed on Kubernetes cluster. If you are not aware about this particular process, I also have another video about that explains how to expose your application to the outside world. Now, as we discussed, there are two ways, there are two steps. One is creating a service and another one is creating an ingress resource. And after these two steps, an external user would be able to access your application that is deployed in or that is deployed as a deployment named D1. Now, what our custom controller is going to do is, let's say this is the controller that we are going to write. Controller, as soon as a deployment is created, this controller is going to create this service and the respective ingress resource automatically, so that all you have to do is deploy an application on the cluster and application would be exposed to the outside world automatically. And this is what our custom controller is going to do. We are going to call it expose because eventually it is going to expose our application automatically to the outside world. Now that we know the use case that where we are going to use this controller, let's just go ahead and try to look into low level building blocks of this controller. Now we should somehow, or the controller code that we are going to write should somehow get to know when a particular deployment resource is created, and only after that it should create or it should expose that deployment resource. So we can either use watch verb that we have already talked about, and we also know that we should not use watch verb. Instead, we should use informers. Now, again, if you don't understand why we should use informers, what are informers, I suggest you should watch the video that I talked about. Once we have informer, what we are going to do is we are going to register some functions, so that as soon as a deployment is added, deleted or updated on the cluster, these registered functions are going to be called. So we are going to register a function, let's say handle add, similarly handle update and handle delete, and these functions are going to be called as soon as a deployment was either added, updated or deleted on the Kubernetes cluster. Once these functions have been called, all they are going to do is they are going to make an entry on a data structure, a queue that we are going to maintain as part of our controller. So let's say this function was called with an object obj. Obviously, if you talk about handling add of deployments, the deployment that was added would be passed to this particular handler function, and we are just going to add that in this data structure that we maintain. Now there is this another function or another routine that we would have, and this routine is going to get objects from this queue that we are maintaining, and then actually going to do all the business logic here. So do stuff, let's say, and this stuff in our case is going to be creating service and ingress, so that the deployment that was added can automatically be exposed. So yeah, I mean, these are all the building blocks that we are going to use to write this custom controller that we are talking about. If you have a question about any one of these, I would suggest you to ask them. I would be happy to answer them in the comments section. Now that we have decided the basic building blocks, the use case, let's just go ahead and try to create this Go project. So go mod init, and name of this project is going to be expose, and it says that a go project has been initialized. Let's open that in our text editor. Yeah, now I'm going to refer a project, a very simple Go project that we have already written in one of the previous videos, to set up a very basic structure of this custom controller. So what we are going to do is, let me just maybe copy paste this thing. So I'm not explaining this because, as I said, this is basic that I have already explained in one of the previous videos. So if you watched that, you would very easily understand why are we doing these things that we are doing here. And as soon as I save, all these dependencies have been downloaded, or sorry, imported or added in the project. Now just to remove this error, what we are going to do is we are going to say print client set. Now let's just go ahead and try to build this project. What I would like to highlight is this is all we are doing is we are trying to read kube-config file from this particular location, or using the flag kube-config, and we are building client set for, or using that kube-config file. That's pretty much it. And if you want to look into the details, you should watch the video that I talked about. Okay, this is pretty standard error, so I exactly know how to resolve this. So since we are using client go this version, let's update this to 21. So go git @ and the version that you want to download is this, let's say. Now it should be resolved. Okay, we should have a binary named expose, and as you can see here, we successfully got client set. Now all we have to do is we have to create, if we refer to this particular diagram, we have to create informer for deployment. And how we are going to do that, we are going to create shared informer factory. So let's just go ahead and try to do that. So informers dot new shared informer factory, and this is obviously going to take client set. we have to, once we have shared informer factory, let's I think it returns informers and error as well. So if error is not equals to nil, in that case what we are going to do is we are going to, let's say, print the error. Okay, now that we have informer, what we are going to do is we are going to create the controller that we talked about. So let's just go ahead and try to create another source file named controller, and this is going to be in the same package for now. Let's say for the sake of simplicity, what I'm doing is I'm going to create all these source file in the same package, but in actual production controllers, you would see that they are on the separate uh, inside separate packages. So let's go ahead and try to create controller, and this is the controller that is going to have all those methods that we talked about and this routine that we talked about, etc. So if we talk about the fields that this controller is going to have, so first of all we would need client set to interact with Kubernetes cluster. For example, once we have this object, we are going to create that object, or we are going to create service and ingress resources in Kubernetes cluster. To do that, what we would need is we would need client set, and client set is going to be of type Kubernetes dot interface. Once we have client set, what we would need is we would also need lister, and lister is the component of informer using which we get the resources. Again, I have already talked about informers, listers in detail in the videos that I have been talking about. So we are going to call it, let's say, deployment lister, and type of this deployment lister is going to be, so I'm referring to the code that I have already written. So it is going to be apps listers dot deployment lister. And once we have a deployment lister, we should also have a way to figure out uh, if cache has been, informer maintains a cache, and if that cache has been synced or that cache has been updated. So we are going to call it deployment cache synced, and I think the type is informers dot has cache dot informer synced. So we are going to do apart from that, we would also need a queue, as we have discussed in this particular diagram, so that as soon as these registered functions are called, we are going to add that object in a work queue. So okay, and let's call it queue, and this is going to be from work queue. once we have this at least controller struct ready, let's just go ahead and try to create a function that when called is going to return a controller, so that we can call that function from main and we can run the controller. So let's say func new controller, and it is going to return pointer to controller. So and this is what we are going to return. Now if we talk about how do we want to initialize these fields that we have here, so if we talk about client set, we can easily get client set from main that we have already initialized. If we talk about deployment lister, again deployment lister can be we can get deployment lister from informer very easily, and we can figure out deployment cache synced from the informer itself, and queue can be initialized. uh, this is interface, and we can initialize this queue with actual implementation of a queue. So let's just go ahead and try to do that. We would want client set here of type Kubernetes dot interface. We would also want deployment informer, and deployment informer is going to be of type apps v1 informer dot deployment informer. So this is where our deployment informer is going to be. So apps informer dot deployment informer, and I think this is pretty much it that we are going to need to initialize this controller. So we are going to say client set is going to be client set, and deployment lister is going to be deployment informer dot lister, and deployment cache synced is going to be deployment informer dot informer dot has synced. And we will also have to initialize queue, and queue is going to be work queue dot the queue that we are going to use is new named rate limiting queue, and this is going to have, or this is going to expect rate limiter. So rate limiter is going to be work queue dot default controller rate limiter, and we are going to pass the name as well, and let's pass the name to be expose. We can also have that as a constant, but I think this is okay as of now. So I'm just referring to a code that I have already written, but if I try to explain it to you once again, what we are trying to do is we are trying to initialize a controller that is going to run this go routine continuously that we talked about, and this go routine is going to get the objects from the queue that are going to be added by the handlers that we are going to register. So before returning the controller, what we are going to do is we are going to register those functions. So deployment informer dot informer dot add I'm just trying to build this controller here. All right. Okay, so once we have deployment informer, we are going to add handler functions that we just talked about here, and we are going to do that using using these hooks. I would say for add func, let's say I want to call a function named handle add, and for delete func, I'm going to call a function named handle delete. Now we also have to define these functions, and the type of these functions is if you see here, func object interface. So a function that takes an object of type interface. Similarly, we are also going to have another function named handle delete, and this function should be of type the same signature, so object interface. So yeah, I think after what we have written, we have a controller struct, and we have registered two functions, add func and delete func. Once we start informer, excuse me, we should be able to call, or these two functions should be called as soon as deployment is either added or deleted from the Kubernetes cluster. Now, if we talk about the actual run of the this controller, let's just go ahead and try to implement that function. So run, and what run is going to do is, first we will have to wait that the informer cache, so informer maintains a local cache, so we will have to make sure that the informer cache has been synced successfully. So to do that, what we have to do is cache dot wait for cache sync, and we have to pass it a channel, so channel of type empty struct. So let's take an input of channel of empty struct, and that is going to be passed, and we also have to pass the informer linked, and we have, if you see, this is the type that we have for our deployment cache synced. So what we are going to do is, all we are going to do is we are going to pass the same thing to wait for cache sync. So c dot deployment cache synced. Now if this is not done, so it simply means that there is something wrong, there was something wrong while waiting for the cache to be synced. Let me try to explain this once again. So I think I have already discussed about this in some of the previous videos, but since Informer maintains a local cache, we will have to wait for that cache to be synced, or that cache to be initialized, at least for the first time. And that is what we are trying to do here. So wait for cache sync. If this failed, it simply means that there was error waiting for cache to be synced, and error is this. Okay, now let's just log here println starting controller. Now what we have to do is, if you remember, these two functions are going to add objects to a data structure, to a queue, and we also discussed that we are going to run a routine, a function continuously, right? So let's try to implement that now. So we are going to use again a function from API machinery, uh, wait dot until, and what it does is it calls a specific function after every duration until this particular channel is closed. So if you see the description, until loops until stop channel is closed, running f every period. So this function is run, the function that we are going to specify, that function is going to be run after every period until this channel is closed. So if we don't close this channel that we are going to pass, this function is going to be called after every time that we specify. So let's call this function c dot worker, and we are going to specify the time to be 1 into time dot second, and the channel that we want to pass is, here we go, and we are going to run this as a go routine. Now let's write function worker, and here we go. So now it looks like we have a very basic, at least skeleton of a controller. All we have to do is we have to run the controller from main as well as the informer that we have to start the informer. So let's just go ahead and try to do that. So controller is going to be new controller, it expects client set and expects deployment informer. So we are going to get deployment informer like this, and we are going to run we are going to call c dot run with a channel. And we know that why do we need this channel? We need this channel because we are going to call this function until this particular channel is closed, and wait for cache sync is also is also expecting a channel. That is the reason. So let's just go ahead and try to create a channel. So ch colon equals to make channel of type empty struct. Now if you are not very familiar with Go programming language, this might be a bit confusing to you, but I would recommend just going through the video, and you would at least get to know the basic building blocks or constructs of a Kubernetes custom controller. Now we are going to pass ch here, and we are also going to start the informer, and here we go. So as soon as we run this, let's also include some logging here just to make sure things are working as expected. So add was called, delete was called, and let's just go ahead and try to build this again. So go build, so this is going to finish. All right, our controller that we have written should always be running. So if you see here, this runs and the controller runs and it returns, but it should not get completed. All I'm trying to say is it should always be running, and it should listen for the deployment resources, and that's happening because we are calling this in a go routine, and go routines are obviously non-blocking, so it would get called and it would successfully return. So what we can do is we can wait for something to be there in the ch, and if we don't put something in this particular channel, this particular function would not actually return. So if we go build this again and try to run the controller, now at least this should be running continuously and this should not return, and here we go. So we see these two functions because it looks like two deployments are already there in the Kubernetes cluster. Now, if I go ahead and try to create a namespace, let's say create namespace expose test, and if we create a deployment in this particular cluster, so kubectl create deployment -n expose test and -- image equals to nginx, and name is going to be nginx. And here we go. As soon as the deployment was created, our controller that we have written here was able to figure things out, and that was the reason we just got add was called. And if I delete this deployment, we should get log that delete was called as soon as this deployment is deleted. And here we go. So now we for sure have a basic skeleton of the controller that we want to write. Let me just go ahead. I think there are a lot of things here, so let me just go ahead and try to explain this once again. So if we look into this particular diagram, we discussed that we would need informer instead of watch, so that we can get to know, we can get notified as soon as a deployment resource was either created, deleted, or updated. And to do that, what we did is we created informer factory, and we passed informer or deployment informer from that informer factory to the controller. Now, in controller, what we are going to do is we are going to register these three functions for add, update, and delete events. Once we have registered these functions are just going to add the objects to the queue, and there would be another routine that would be running. So for example, this is the routine that I'm talking about. So worker, this is going to continuously run a function, and that function is going to get the values from this queue that we talked about, and then is going to do certain things. So let's just go ahead and try to improve this. So add was called, and all we have to do is we have to add this object in the work queue, or the queue that we have. So c dot we'll have to associate these functions, or we'll have to make these functions methods of controller, so that obviously we can access fields of controller. All right, so what we are going to say is c dot q dot add and object. Similarly, what we are going to do here is c dot q dot add and object. So what we have done is we have at least implemented this part where we have to add the object in the queue. Now that we have added the object, this function is going to do the actual magic. So what we are going to do is we are going to run a function infinitely. So let's call that function func process item, let's say, and this is going to return bool. So we have to call this function, I would say, infinitely, and this function is going to get the values from the queue. So to do that, what we can do is c dot process item, and this is going to return bool. And if it's going to return bool, this function would continue. If this is going to return false, in that case this worker would return, and once worker would return, wait dot until is going to call the worker once again after 1 second. So I hope this makes sense. And this is going to do that because we are not closing ch anywhere. if you see here, until loops until stop channel is closed. So this channel is not being closed. That is the reason. Even if worker returns, go.wait dot until is going to call c.worker again after a second. And this is the actual function where we have to implement our logic. So let's just go ahead, and first of all what we have to do is we have to get the item from the work queue. So c dot q dot get, and this returns item and shutdown. So item and colon shutdown. So if shutdown is true, in that case what we have to do is we have to just return false. And if shutdown is not true, in that case we have gotten this object into this function, and we have to now do the things that we want to. So now that we have this object is of type namespace and name. So what we have to do is we have to call cache dot meta namespace key func. This expects item, and this is going to get us name space colon name. This is going to, hold on, let me refer to the code that we have already written. Okay, so it gets us key colon error, and it gets the item. Now if error is not nil, in that case let's say we want to print getting key from cache, and this was the error. Now that we have key is of form namespace colon namespace and name. So we will have to get that by calling this another utility cache dot split meta namespace key. It gets key, and that's pretty much it. And what it returns is it returns namespace colon name. So ns colon name and error. So ns name colon error equals to this. If error is not equals to nil, in that case we want to there are a lot of ways to handle these errors. For example, you can use another package from API machinery to notify these particular errors, so that these can be logged, and these errors can be used in auditing, etc. But right now I'm just using fmt.print to print these errors. Obviously we are going to improve this in further videos. So splitting key into name space and name, and the error is this. Now that we have name and namespace, what we are going to do is we are going to create service for this particular deployment. And we know this is deployment because the informer that we have created is deployment informer. Okay, so what we are going to do is we are going to call c dot, let's say, sync deployment. Okay, and we would return false. We would return false from here as well, and if things are working as expected, we are going to return true. Now here is the thing. If we talk about this particular scenario, when I say sync deployment, I mean the things that we want to do once a deployment resource is created, and if that fails, we wouldn't necessarily fail here. I mean, there are chances that we would want to retry. So let's just comment retry here, and to retry, what we can do is we can add this particular object into that queue once again. So for example, if you look into this particular diagram, if we tried to do some stuff with object that was not successful, what we would want to is we would want to maybe retry for that particular object. So that is why I'm adding a retry here, and sync deployment is going to be called with ns and name, and let's just go ahead and try to implement controller and sync deployment. It is going to return error, and it is going to get ns and name. Okay, now all we have to do is we have to create a service and create ingress for this deployment that was created. To do that, let's just go ahead and try to create a very basic service struct, and we can do that by we know that service is from core v1. So core v1 service godoc. We are going to call it core v1 and core v1 dot service, let's call it svc colon equals to this, and we are going to create a service now. So we obviously have client set, so c dot client set dot core v1. Again, if you are not familiar with this particular syntax, I have already discussed about this in that playlist that I talked about. So dot services, we are going to specify names is here dot create, and it expects a context. So let's create that context. So context equals to context dot background context and service that we want to create. So svc, and we also have to specify create option, and this is from meta v1. So let's just go ahead and try to get that package as well. So I think it's so meta v1 dot create options. This should work. It would get us service and error. So we don't want service as of now, but we have to check if error is not nil. In that case, we have to log creating service, and the error is this. So error dot error. Now after this, we should have a service created. So let's just go ahead and try to build this again. it looks like this package that we have included is incorrect. So let's just go ahead and try to figure that out. So meta v1 dot create options codoc. So this is from API machinery, and that was the reason we were having that error. So this is how it should look like. Yeah. And it expects here we go. So now what if you, I mean, you might have figured that when we are creating a service, we are not specifying anything. I mean, we are not specifying which particular what should be the name of the service, which particular namespace the service should be created in, and things like that. So let's just go ahead and try to do that. So object meta, and for object meta what we want to specify is name. So name of the service is going to be we want to name the service same as to the deployment name. So we would want the deployment name somehow. So what we are going to do is let's get the deployment, and here is where the beauty of Informer comes into picture. Apart from the other places that we have used, we are going to get the deployment from the lister. Now we are not going to call API server. So what we are going to do is c dot deployment lister dot deployments from namespace ns dot get, and name is going to be name, and this gets us deployment. Getting deployment from lister, and the error is this. So we are going to name the service as deployment.name, and namespace is going to be the namespace. Now we also have to specify which particular port this service is going to forward the request to. So we have to specify port as well inside spec, and ports the name is going to be, let's say, HTTP, and the port is going to be 80, because we know that Nginx, we are exposing Nginx deployment, and Nginx deployment listens, or Nginx container listens on port 80. Now we have to heavily modify this. We have to modify this to figure out the port our deployment's container is listening on, because it's not necessary that the container is always going to listen on port 80, and we can also do something about this port name. So I hope this makes sense. If we talk about service, spec of service is of type core v1.service spec, and ports are of type core v1.service port, and things like that. If you did not understand this, let me know. I can make another video about this. So it should make sense now. Let's just go ahead and let's just go ahead and try to run this now. So go build, and expose. So let's just go ahead and watch for services from expose test. namespace. So we don't have any service here. As soon as we create a deployment -n expose test -- image is going to be nginx, a service should be created in the same namespace if everything goes fine. So let's just, and here we go. As you see here, this service was created with type cluster IP because we have not specified any type, and by default cluster IP type of service gets created. We have specified port and etc. Now to actually test if things are working, what we are going to do is we are going to port forward localhost to this service, and we are going to access the nginx application. So kubectl port forward to namespace expose test svc nginx, and from localhost 8080 to the port 80. Okay, and as you see here, it says service is defined without a selector. So it simply means that we have specified the service, but we have not specified which particular backend pod this service should redirect the traffic to, because that is the whole purpose or motive of services. So when we create service, we also specify, obviously using labels, which particular backend pods this particular service should forward the request to. So let's just go ahead and have a look into the service, how it looks like now. So kubectl get service from expose test namespace nginx -o yaml, and if you see here in spec, we are not specifying any selector, and using selector we specify which particular pods this particular service should forward the request to, and all the pods that match the label that we are going to specify in service selector are the pods where this service is going to forward the request to. So let's just go ahead and try to do that. So I think this is where we specify selectors, and selectors are of type map of string and string, and for selector we'll have to specify the pod, the labels of the pod. So let's just call get pod or pod labels and store it in labels for deployment, or let's say deployment labels for deployment, and let's implement that. So func and we are going to get deployment. So deployment is of obviously apps v1 dot deployment, and we are going to return deployment dot so we know that deployments are part of apps v1 API version, so that is the reason we are going to use apps v1. And we are going to return deployment dot spec dot template dot labels, map of string and string. Okay, So now it looks like it should work. So let's just go ahead and try to build and run this again. So go build, and we will also delete the service and deployment from the expose test namespace. So delete all from expose test namespace. Okay, let's run expose, and what we are going to do is, so these services were created from the previous run, so we are not worried about them as of now because we are just targeting this specific namespace. So let's just go ahead and try to create another deployment. So kube create deployment in namespace expose test, name nginx, and image is going to be nginx, and we should have, here we go. So we have a service created automatically. Now if we port forward to that service, and here we go, we are successfully able to port forward localhost 8080 to the service nginx from this particular namespace. And let's just go ahead and try to access that. So localhost 8080, and here we go. So yeah, the other very important thing I would say that I wanted to talk about is, when we call sync deployment, if everything goes fine, what we have to do is we have to make sure that this particular object is not processed again. So in to leverage that, to do that, what we do is we have to call c.work queue.Forget, and then item. So if everything goes fine, we want to forget this item, and so that we don't actually process that item once again. So yeah, obviously there are some improvements that we are going to do in this particular project in some of the coming videos. For example, we have just automated creating this service, but the other step is to create ingress additional to the service that we are creating, and that is what we are going to do in the next video. I hope this made sense. So let me try to summarize this once again. So we wrote a controller that does create service as of now. So this is what we have automated. This is what is being done in this video. We are going to implement this in the other video, and I'm going to obviously push this entire thing on my GitHub repo, and I would link the GitHub repo in the description. So if you want, you can maybe contribute there as well. You can change some code, you can add maybe a readme and things like that. This was a lot, I would say. If you have any question about any of these things, first of all, I would recommend you checking out the playlist about basics of client go, and then you can obviously ask any question that you have in the comments section, and we are going to consistently improve this custom controller that we have written. This was pretty much it from my side. Thank you so much for watching. I'll see you in the next one. If you obviously liked this video, you should consider subscribing. You should share the video with your friends, colleagues, or classmates. Thank you so much.